What's up, everybody? Welcome back to another live stream from the Scalar Learning channel, 2 in 1 day. All right, but this is a video that I had to make. I was actually going to shoot it and then post it, edit it and post it and all that, but I actually think this is going to be the best. So we're just going to jump right on, and I'm going to give you all the Desmos hacks that you can use for this test. And again, the idea is that literally there's so many amazing things that you can do with Desmos on the digital SAT without knowing really much math. You can just use the calculator as an incredible tool. So what we're gonna do to show you how to do this and show you how powerful this can be is I'm taking practice test 4 from the College Board, and I'm gonna skip every question that I can't purely answer on Desmos. If I can't purely answer with Desmos, I'm gonna skip it. And we're gonna get everything right with Desmos, and we're gonna see the score. So this is gonna be kind of like what you can do if you know nothing and you're just leveraging heavy the Desmos calculator, which again is an amazing calculator. All right, without further ado, we're going to jump in the mix, and this is going to be a nice tutorial. After the fact that after this live airs, if you're watching it in the replay, we're going to have all the timestamps posted. We're going to, enumerate everything really nicely, so it's going to be really cool. All right, ladies and gentlemen, without further ado, we're going to start in 3, 2, 1. Let's go. Okay, so then it's set here. I'm going to solve everything on the calculator, okay? So let's get this here. It says if x equals 7, what is x plus 20, right? So they want to know what is x plus 20. And actually, let's do it like this. Let's say c plus 20, because then we can add a slider. And they're saying when c is 7, what is the value? 27. Boom, done. Okay, moving on to the next one. So that's just a little plug and check. Here we're trying to find the mean, okay? Let me show you how to calculate means here, okay? So we have a function. Hold on, let me show you in Desmos, which is super cool. Where is it? Can you say mean? I think you just say mean. Mean of 5, 9, 9, 13. Hold on, let me see if that is it. Yep, amazing. Look at that. It calculates it right there for you. Just type. You'd be like, you might not even remember what mean is, but just type in. Hey, they want the mean. Let me type it in. 5, 9, 9, 13, 27. So they have this really awesome thing. And now you can see the second mean of data set. Well, I mean, you could eyeball it too. I'm not saying you can't, but I'm saying if you don't know or remember what mean is, you can just type it in. Which one's bigger? Y has a greater mean. The mean of data set X is less. There you go. Boom, done. Number 3. Not drawn to scale corresponds. Okay, this one you can't really use the calculator. You got to know the language of what this means. So we're just going to skip it and leave it blank. Kilograms every 21 seconds after launch. Boom, boom, boom. Remained on average. Okay. Okay, here's how I would use the calculator. So we're going to kind of piece it together. So it's a little, could we use Desmos on this? I mean, you can, but you kind of have to understand. It's not like you can totally know nothing. So let's put it like this, right? Here's how I would do it in the calculator, but I'm kind of leveraging a little bit of knowledge, okay? So I know that we have this much, and then we eventually have this much. So I'm going to take the difference of these two, and that's how much was burned, right? We burned this amount, so I'm going to paste it in here, or, well, I can't paste it, 104,895, and then that's after 21 seconds, so then I divide it by 21. Anyways, that's how I would get this answer. So that's how much it would burn each second after launch. I can't totally classify that as you don't have to know anything. You kind of have to understand the numbers and whatnot, but boom, there you go. Okay, solution for a system of equations. This is amazing, right? All you're going to do is be like, what are they talking about solutions? Well, all I'm going to do is I'm going to plug in these two equations, 4x equals 20, and then negative 3x plus y equals negative 7. That's the beauty of Desmos. You type it in as is. And what is the solution? It's where they intersect. Boom, 5, 8. And our answer is 5, 8. Oh, they want x plus y. So 5 plus 8, 13. C is the winner, done. Okay, next. They got this linear equation, x is the number of on-site training, blah, blah, blah. How many more hours does each online okay, this is an interpretation question, so you can't really use Desmos, so we're going to have to skip it. Next, square x is side length of 12, perimeter of y. I wouldn't say you could just go straight up and use Desmos here because, you still need to draw this out. Perimeter square y is 2 times the perimeter square x. Yeah, this relates to side and perimeter relationships, which are equivalent, but let's skip this one. Okay, this one, we have, according to the model, how many gallons of gas are used to drive each mile? Okay, so this is like an interpretation question, so you can't really use Desmos. You have to know what's the slope and what's the y-intercept, so we're going to skip it. Okay, what is the positive value? Straight up, right? Watch this. Absolute value of 4x minus 4. And by the way, we're trying to get x minus 1, not x. So here's how I'm going to do it. I'm going to say 4x minus 4 as one side of the equation. I'm not going to say equal to 12. I think this will, I don't even think that'll give me, yeah, this will give me this, which you can interpret, okay? And you can get through your answer and you can recognize, actually, this is fine. Right here, look. So you can see it goes through at 4 and negative 2. Those are my two solutions, 4 and negative 2. Negative 2 minus 1 is negative 3, but 4 minus 1 is 3. And that's it. Just plug and chug, boom, done. Next. The equation, you can't really use Desmos here. Exactly. This is an isolating quantities question, so we'll skip it. This one, table shows 4 values of x in the corresponding. There's a linear relationship between, okay, defined by this. Okay. I'm going to show you a really cool way that you can hack this with Desmos. So watch this. We're going to, I'm not saying this is the fastest way. I'm just saying purely with Desmos. We got coordinates here, right? 10, 82, 15, 137, whatever. Okay. So we got a couple of points. Let's find those points because now I just plotted them out. You see how we can plot coordinates? So there they are. Now what we're going to do is we're going to say the function, which I can also just say y, is mx minus 28. And guess what? Now we have a slider. Okay? And all we're trying to do is we're trying to get this equation to match up with these coordinates. Watch this. Watch how cool this is. Do. And then you can kind of get to that point. Ooh, okay. It almost worked. Wait, hold on. 10. Let's try, hold on, here. Let's try 11. Okay, it's probably 11, all right? But you see how we can just do it graphically. Now what we're going to do is I'm going to straight up plug it in, and let's see if it actually hits those points. 10, wait, what is this point? 1082. Well, if I plug in 10, I get 110 minus 28, which is 82. I plug in 15, I'm sure I get that. Yeah, so 11. We use Desmos, boom, done. Okay. This one is equivalent to this. Okay, wait. You can use Desmos for this too. Watch this. Watch this. So when we're talking about equivalent expressions, right? Instead of using x, I'm going to use c, okay? Because you can set what's it called? Minus 3. Oh, hold on one second. Whatever. Okay. Sorry. All right. So then, look, I'm going to play negative 5c cubed minus 3, and then we got minus negative 4c cubed plus 8, okay? And we'll add a slider for c. Cool. It doesn't matter. The c is arbitrary. And then now we got this other equation. I'll say bc cubed. So again, c is now x minus 11. And we're trying to get these to be equivalent. So right now, that one equals negative 12. This one equals negative 10. So this is not going to be the most. Oh, look, and then you can use the slider. So look, we're trying to get negative 12. As I'm sliding it this way, I'm going away from negative 12 this way and right there. And b is negative 1. It worked, okay? And now I can let me just make sure that was right? So you add those together, then you get 9x cubed. No, that didn't work. The answer should be 9, not that. Oh, wait, I probably typed it in wrong. That's why. No. Oh, that's why. Look, I messed it up. Here. So then now, with c equal 1, we need to get an answer of negative 2. Sorry. So let's slide it so we get negative 2. And there it is, 9. And b is 9. That's correct. Okay. I'm going to still say we got that purely with Desmos. I just had a typo. So boom. Next. This is going to be amazing too with Desmos. Watch this. So again, we're going to type in the inequalities. Here, check this out. So the system of inequalities, y is greater than 14. And then over here, 4x plus y is less than 18. Okay, so this is a system of inequalities. And again, the solution is where we got shading for both, okay? So the point x53, which of the following could be the value of x. So now watch this. I'll say x comma 53, and then we can just plug in these different values of x. So negative 9, negative 5, watch this. So we'll say, actually, let's do a slider. C. So first we have negative 9. Let's try that. Nope, it's on the line and it's dotted, so that's not part of the solution. Negative 5. Nope. Oh, wait, let me zoom in. It's so zoomed out. Hold on. Wait, let me make sure the -9 wasn't good. -9. Oh, wait. Oh, it's inside. It's inside. -9 is correct. And then just to check the other two, 5 and 9. Sorry, I didn't realize I was so zoomed in. 5, definitely not, because that's going to be over here. So that's out. And the 9's obviously even farther out. So anyways, -9. A is the winner. Done. Oh, and then you could plug in 53. Well, 53 obviously works. -9, -36 was 53. Yep, it works. There were 300 cells initial. The number of cells doubles every 3 hours. How many cells will there be? 15 hours. So the way I would do this in Desmos is as follows, okay? I would say how many cells per millimeter will there be? 15. Okay, watch this. This is how I would do it. I would say we're starting at 300,000, okay? And then after, it doubles every 3 hours. So after, here's, well, it's not working. Hello? What's going on? Why is Desmos not working? Let me try again. There we go. So I would say that's after 3 hours, doubled. After 6 hours. After 9 hours. After 12 hours. After 15 hours. And you can do something like that. So don't even mess around with trying to create an equation. If you're going pure Desmos, just plug and chunk, boom, 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 done. All right, next, the graph invites... Nope, can't really do this with Desmos. This is an interpretation problem, so we got to skip it. This one you can do with Desmos. Watch this. Ready? This is going to be amazing. So, first of all, we need to get that radical. Where is that tool? Functions. Where's the radical? Here it is. Okay, so we want 7th root. And again, instead of saying x and y, I'm going to say b and c, because I can add sliders for these. And then we'll say, because again, with equivalent, we just want the right one to be the same value. And I can set b and c to anything. I just not crazy about 1 and 2, but how about 2 and 3, okay? And now we need to know which one it is equivalent to. So let's write all these out. Let's say BC to the 7/9. Hold on. BC to the 9/7. Again, I'm not saying this is the fastest way. I'm just saying this is going in blind to the test. This is a way that you can hack it, okay? And then BC 63. So you see how I'm kind of plugging in all these values? And we're using the same BC. So equivalent, whatever I get up here, I should get down here. So I get 10.0 whatever. I see that in option B, and that's it. Now, does that make sense? It absolutely makes sense, right? That's the numerator is the power. That's the denominator. So it should be 9/7. But anyways, that's how you do it in Desmos. Boom, done. 17. Increase from this to this. Wait, you can kind of do this in Desmos. All right, so you kind of have to understand what a percentage increase is. Okay, here's how you could do it, I suppose. If you're talking about, if you're saying like, hey, the original because you know what, if the original population is 100, the new population should be 107, all right? Right? So let's take that estimate. So, so we're taking one of these values and multiplying it by 100, and we should get 107. So you do 0.07 times 100. Hold on, let me move it over. And that gives you 7, so that's obviously wrong. Then you try the next one, 0.7, that gives you 70, that's wrong. Then you try 1.07, and that gives you what we want, 107. So this is one we can count as answerable. Boom, done. Number 18, which of the following has no solution? Okay, beautiful. We're talking about systems. We're immediately plugging these in, and we're looking for whichever one has no intersection point. So let me delete this, delete this, delete this. Okay. First one is x equals 3 and y equals 5. So they are going to intersect, see? And then next we have, okay, I'm going to go to the, it's just to show you, I'm going to go a little, you just plug in and see every one of them that they intersect. That's not it, right? Because we're trying to find a no solution, meaning they're parallel. So let's pretend we're going straight to option C. So it'd be like, all right, this, and then y equals 16x plus 19. And then obviously we have to zoom in, and then you see, oh, look at that, they're parallel. They don't seem to ever intersect, right? You might have to double check and look around. But yeah, that's fully answerable on Desmos. C is the winner, boom, done. Okay, W and term, Okay, watch this. Again, I can also do this in Desmos. So the first term of the sequence is 9, and then each term after that is 4 times the preceding term. What does that mean? That means that we should have 9, then we have 4 times 9 for the second term, and then we have 4 times 4 times 9 for the third term. So this is term 1, 2, and 3. 9, 36, 144. Okay. And so we should be able to, so now with these ones, we should be able to plug in 1 and get 9, 2 and, I'm sorry, 1 and get 9, 2 and get 36, etc. Okay. So let's say, you'd write them all out. Let's pretend we're going with option D, okay? I know I'm kind of hacking it a little bit because I'm jumping straight to the right answer, but just let me show you, right? You would do the same thing with all of these. So C minus 1, and there we go. And, okay, so then now we're going to plug in a slider. So when it's 1, look at that, we get 9. When it's 2, we get 36. And when it's 3, we get 144. We verified it straight up on the calculator, pretty much without knowing anything. So D is the winner, done. 20, okay, the minimum value of X is 12 less than 6. This is kind of interpreting the equation. Desmos not really going to help you, so we're going to skip that one. This is not going to, Desmos isn't going to help you with this either. Oh, wait, would it help you? Nah, it's too, I don't think you can hack this one with Desmos. Okay, this one is great for Desmos. Watch this. Hold on one second. So we got 9x minus 10y equal to 19. And they said it's translated down 4 units in the xy plane. Well, look, check this out. You can kind of, I can't really annotate, but if we're going 4 units down, we go 1, 2, 3, 4. And and we want to know what's going to be the new x-intercept. Okay, so what point is 4 above the x-axis right here? Wait, did I write that right? 9x minus 10y. Okay, I'm going to show you a better way to do this, okay? Instead of trying to graph it out, because it's going to be a little bit tough to see. I don't know. I think it's going to be like 11 probably. Oh, you can see it right there. It is. Yeah, so 11 is exactly, it's 8 above. It was scaled. The scaling is, you got to be careful on Desmos. Okay, hold on. Here, where is that 6.5? Where is it at 4? Hold on, y equals 4. So it's that value. That's not even, okay. I'm going to show you another way in Desmos to do a vertical translation down. You're just going to be minusing 4 against the y. Or wait. Am I doing that? No. Plusing 4. Sorry. Okay. You have to add 4. It's sort of like you have to do that reverse. No. Something is really funky here because we're getting some weird like decimal. I mean, which it could be correct. It's just, we'd want to put in the fraction version of it. Okay, hold on. Let me just verify this in my head. So then we'd have 10y, here, 1 second. Yeah, I mean, it's 6.556. I guess we can enter. No, I mean, hey, let's do that. What is the decimal doesn't fit? Truncating right into the 4th digit. Okay, so let's just do that. So I'm going to pretend like we're doing this just straight up off Desmos. I won't get the fraction equivalent, so I'll just say 6.556. And that's it, 6.556. So we did a translation down by 4 units, and that's that. Okay, we're going to see what we got. I don't even know if that's going to take us to the harder module 2 or the easier one, because I don't know how many we got right, but we're going to see the score at the end. Okay, next. Okay, we can do this in Desmos. Of those surveyed, 20% responded, and so they intend to enroll in the study program. So how do we take 20%? You just convert it to the decimal equivalent, 0.2 times 55. And I guess you do need to know that you got to convert it to that decimal equivalent. But yeah, I mean, it wouldn't make sense to be 1100 if you multiplied it by 20. So we'll count that. 10 minutes make large. You can't really use Desmos because you got to understand what it's talking about and how to frame it. Okay, the scatter plot shows relationship between two variables, x and y. Line of best fit is also shown. Which of the following equations best represents the line of best fit shown? Yes, you can totally do this in Desmos. Okay, watch this. Here we go. We're going to go through all our answer choices, and we want the graph to look just like this with the y-intercept of about 13 is what it looks like. So we'd say y equals 13.5 plus 0.8x. That's a positive slope. You can already see that's wrong. Y equals 13.5. I don't even need the y equals, just FYI. That one looks wrong, obviously. Oh, wait, no, I flipped it. 13.5, sorry, minus 0.8x. Oh, that one looks really good, right? Look at that. That looks really good comparatively. And where does it hit it doesn't show it hitting the x-axis. But, but it's hitting the x-axis before 14 here. It's not. So that's almost good. Although that should be the right answer. Wait, hold on. That should be the right answer. 13.5 minus 0.8x. 13.5. Oh, no. 14. Well, that's weird. You see, it's got the right y-intercept, but their x-intercept is funky. Best represents, I guess it's not exact, but yeah, look here. We'll put in the rest just so you can see. Negative 13.5 plus 0.8x. Okay, that's obviously not even showing up, right? That's down there. So that can't be it. And then negative 13.5 minus 0.8x. And so that's basically it. And then see, it's all color coded. So you can see the blue one, which is B, is the closest. Let's put it like that. And it's, oh no, it is right. I was just zoomed up too high. Yeah, it's perfect. It's perfect. Sorry. All right, having little glitches here and there, but we can totally do that with Desmos. Boom. 4. D4 lies shown. What is the value of D? Okay, I'm going to show you how you could hack this with Desmos. But you kind of need a little bit of knowledge. I see a y-intercept of... Okay, so I'm going to put this together as follows. I'm going to say, putting that equation in slope-intercept form, y equals negative 7/8. That's the slope. Negative 7/8 x. Plus 7. Okay, so now we have this line. So look, I'm using a little bit of knowledge to create that equation for the line, but look, it looks good. Now we're saying d comma 4, right? D comma 4. Which one is the right value of d? So now let's use our slider. Let's start with, we just want the point to be on this line. So let's try 7/2 first. Wait, that's right. Okay, I think it's A. Let's try 26/7. That looks above it. Let's try 24/7. Oh, this is a little tougher because, wow, they're really close. 27/8. Oh, they all look like, which of the following, what is the value of D? Oh, no. Okay, oh, wait, there's a much easier way to do this. Never mind, back up. We say y equals 4, and that'll give us the exact intersection point. And the exact intersection point is 3.429. Okay, and now we have to figure out which one of these fractions is equal to that intersection point. 3.429. Let's see. It's not 7/2. It's not that one. 3.4. It's probably that one. 3.42. And then let's see. 27/8. Yeah, it's 24/7. So that counts. You can do that with Desmos. Boom, done. Number 5, throws to which equation defines f. Ooh, again, you can do this with Desmos. Check it out. We are going to put in all of these. Let's see. Hold on. What's the best way to do this? Okay, I know what we'll do. We'll say y equals 3. Again, I'm going to use c, not x, so I can add a slider. Plus 3c plus 14. Okay, and then we need -1 to give us 10. Wait, it didn't give me a slider. Oh, I know why. I don't want the y. We want -1 to give me 10. Nope, it gives me 14. So a is immediately out. Then 5, 1, and 14. 5, 1, and 14. Again, -1 gives me 18, not 10. That's out. So then let's go to option C. 9 minus c plus 14. -1 gives me 24. That's out. And then x squared plus 5x plus 14. X squared plus 5c plus 14. Look at that. -1 gives me 10. And then let's try 0. 14, correct. And then 1 should give me 20, but we already know it's got to be this option. Yay, it works. Okay, so D is the winner. Boom, done. Next. F of A is 10, where A is a constant. What is the value of A? Can we do this? X. Yeah, we can totally do this in Desmos. Watch this. Okay. So we got the function x plus 15 over 5, and we're trying to find what value of x or A is going to give me a function value of 10. So I'm going to plot the y value equal to 10, and now we're going to see where these two intersect. So look. So it tells me that my x value is 35 when I get a function value of 10. Now you can plug it in and double check, but 35 is the winner. We just solved it. Boom, done. This one, I would say, I mean, you can kind of use Desmos, but you have to know the relationship that x equals y and y is supplementary with z and blah, blah, blah. Okay. Okay, let's pretend you know that these two are equal. I think this is fair to use Desmos. We're going to count it. So if you know that 6x plus 13 has to equal 8x minus 29, you get your value of x, which is 21. So then you know that k is 21, and then, or I said x here. So then 6 times 21 plus 13 is 139, which is x and y, and then z is supplementary with that, which means I don't know if I can really add this. You know what? I'm not going to add this answer because I feel like, oops, wait, did I even get the right answer? Yeah, I got 41, right? Oh, that was supposed to be 139. Sorry. Yeah, the answer is 41. I think I'm not going to answer it because I did have to leverage a fair amount of knowledge about the relationship. So let's skip that one. Okay, 8. Line P is defined by this. Yes, totally. We can do this. Here. Okay, I'm going to show you. You can do this by the look test. Let's see how it looks. So we'll say 2y plus 18x equals 9. And then all I'm going to do is I'm going to use the slopes here. And we're trying to find a line that's perpendicular to this line. So there's the line. So we can kind of eyeball it, okay? And I don't care about the y-intercept. So negative 9x. Nope, that's parallel. Negative 1/9 x. That doesn't look like a perfect right angle. Positive 1/9 x. We'll look at that. Nice and perpendicular. And then obviously 9. Oops. Totally doesn't work. 1/9 is the winner. Look, amazing. What a nice hack that is. A sample of O has a density of boo, 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 do, do, do. Nah, I think this requires a lot of knowledge. I've done this problem. You got to draw it out. You got to do the whole thing. I would say we got to skip it. Model's population, according to the model, predicted. Wait, I think we can do this on Desmos. Okay. Watch this. So first I'm going to take my exponential equation, which is 290 times 1.04 to the 4 over 6 x power. No, use a constant. Let's say c. All right. Now, t is years. The population is predicted to increase by n% every 18 months. Okay, so here's how you can do this purely in Desmos. So my initial value is 290. Okay, because that's for initial value of you can plug in 0 and you can see that. Now, we need to see what this gives us after 18 months. Now, c or t is in years. So 18 months is 1.5 years, okay? So that's 301.6. So we want to know, what is that percentage increase? It's going up by how much in 18 months? Well, how much did it go up? 11.6, right? You can just take the difference of these two, 11.6. And then we want to know what is that as a percentage out of the original, which is 290. And there you go, 0.04, which is 4%. Well, that's weird because, wait. Well, I guess that does make sense. Because 1.5, 3/2 times 2/3 is 1. Does make sense. Okay, but that doesn't matter. The point is we did it in Desmos all the way through. It worked. Has no solution. Okay, you can totally do this in Desmos. Watch this. Okay, if it has no solution, then the left side should be parallel with the right side. So watch. 2 times kx minus n. And then the right side is negative 28 over 15 x minus 36 over 19. Okay, and we want these to be parallel, and n is greater than 1. So I'm just going to make n 2 or something. And that's it. Okay, so we need to modify k, and we need to get these two to look parallel. It's you see how it's glitching sometimes? Let me reload that. Okay, let's see if this works now. All right, cool. We need to get it parallel. So -1 is almost parallel. Maybe -1/2. Nope. -7, -8. Oh, whoops. This is going to be a little tricky. I know what it is. It's -14 over 15. But the question is, can you get that with just Desmos? And I don't think you can. Okay, unfortunately, I'm going to say that we can't answer this purely with Desmos, because you got to know that the slopes are parallel and that k times 2 has to equal -28 over 15. So I'm going to have to leave this one blank. Okay, gift shop buys souvenirs at wholesale price, $7, resells them each at a retail price that is 290% of the wholesale price. We can do this in Desmos. So 290% of, that means multiply. So we say 2.9 of 7, and then this is at a discounted price that's 80% off the retail price, meaning we're at 20% remaining. So then I multiply this by 0.2. I think that's fair. $4.06. We got them. Okay, next. In the given equation, the equation has no real solutions. Okay, watch this. What is the okay, they want the least possible value. This one, again, might be difficult because it might be some weird decimal. But let's see. So, again, we're going to add a slider. And when they say no solution, since it's equal to 0, we just want no x-intercept. So, we're going to have to raise it, raise it, raise it. It's raising so slowly. Okay, I guess this one's kind of tough. 100, 1,000. Okay, 1,000 obviously works. 200, 300. Okay, so it's around 300. 290. 289. It's somewhere between there. Yeah, I don't think we could do this because usually what you're doing is you'd use the discriminant and you'd set it to less than 0. So it's -34 squared minus 4 times 1 times c, less than or equal to less than 0, negative. And then you'd solve, but I feel like we're gonna have to leave. Wait. Let me think. Is there a way we can do this? I don't think so. I think we're gonna have to leave it blank. Okay. Data set consists of the heights of 75 buildings and has a mean of 32. Data set B consists of the heights of 50 buildings and has a mean of 62 meters. And okay, I'm gonna say you can do this on Desmos, kind of. You just have to know one little piece of information. Okay, how do I get the total from the number of buildings and the mean? You multiply it. So 75 times 32 plus 50 times 62, and then so there's your total, right? And then did I do that right? 75. Yeah, 75 and 50. So that's my total. So to get the average, you just do total divided by the amount, and then there's your mean. I mean, I think that's fair. So I'm gonna enter it as a solvable problem in Desmos, and we'll move on. Okay. Written as this. Which of the following must be an integer? Wait, can we do this in Desmos? I don't know. Let me try. Okay, so if we did, again, these are equivalent, right? 4x squared plus x minus 45. And then we got hx plus k, x plus g. Oh my god, wait. I don't think this is gonna be so good. So can we do where b is a constant. I feel like there's too many moving parts here to kind of just use Desmos, you know? That's the original. Can we do this with... Okay, so if I tweak h to make it as skinny as that... Well, basically, h has to be 4, actually. I hope that's not kind of cheating, because the reason why I'm saying that is because if that's 4, that has to be 4. So we know h is 4. We know that j plus k is equal to b. I don't know if that really does much. Oh, wait a minute. No. hj plus k. hj plus k is equal to b. So what if we did this? hj plus k is equal to b. And k times j has to equal negative 45. So negative 5 and 9 maybe, and then they should be now they're equivalent. Okay. Does that help us much? So which one of these has to be an integer? Okay, let's see. 36. It's not b. In my instance, b is 29, so I don't think it's a or b because it's prime. What about 45 over h? No, not in this case. 45 over k, yes. Okay, so according to what I did on Desmos, I'm not going to flesh it out. I'm going to say d is the winner. So I think that was a fair way to do it by plugging in the values, just making the connection that b is the same as hj plus k. The reason why I said that is because b is the middle term, and it's like hx times j, which is hxj plus kx. Those are the x terms. And so you add those two together, it'd be the same as b. I think, like, this is a really hard problem, and we just kind of cracked it with Desmos, so that's pretty cool. Okay, anyways, 16. One distinct real solution. We can totally do this in Desmos. Let's do it. Y equals, so again, you get to the difficult problems. Y equals negative 1.5. Y equals x squared. The only thing is, if it's a decimal, it might be a little funky. Okay, let's see here. System has one real solution. Okay, we're going to have to see if this works. If we can get that exact value. Oh, boy. Hold on. 11, 12, 13, 14, 15. Oh, it's going to be a decimal. I mean, negative 1.5. Hold on. It worked! We got it on the money. Look at that. So that means A, what's A is 14.5. We got one distinct solution. I count that as a win. Okay. Cool. 17. 15. You could do this. You could do this in Desmos. It's just going to take so much typing because you're going to have to add 22, 22, 22, 22, 22. Okay. Let me put it like this. The ranges aren't going to change. So if you know that baseline amount of information, when you add 56 to every value, you're still going to have a range of 4. 22 to 26 or 78 to 82. Still going to be, so the ranges aren't going to change. Okay? If you take that, let's get rid of this. Okay. You could do the median. I mean, you should know that the median has to be bigger because you're adding 56 to every value, so all the values are bigger. I'm going to leave it blank. This is not really one you can do with Desmos. Like, that's super helpful. Okay, this one, let's see if we can do it. Okay, it's defined by that equation, a over x plus b, where a and b are constants. If g of x equals x plus 4... I think we can do this. A over x plus b, and we want sliders, and then let's see, we want that point negative 10, negative 1. You kind of have to know some stuff. Like, I'm pretty sure they want b to be 4. And I know that because of the vertical asymptote here, it looks like it's at -4. But see, I'm kind of cheating because you have to know that for the rational functions. And then I don't know. I'm going to have to say this is not solvable, I think. Because even if we start moving it around, maybe, would this help? Well, wait a minute. Wait a minute. That kind of works, right? So then we got that nice -10. Oh, no. Is that a half? It's supposed to be at -10(1). See, my scaling gets off. I got to be careful. Okay, sorry. Oh, wait a minute. You can kind of do it. And then it's at 6. -10, -1. Wait, we just did it. Okay. Maybe I'm going to count that. Okay. And then which equation could define g? So f of x is shown, and then we want f of x plus 4. That means we plug in 4, x plus 4 for x. So then it's 6 over x plus 8. Which is C. I feel like we did it. I feel like we did that in Desmos. I'm going to count it. All right. Next, 19. In the given equation A and B are the product of the solutions of the given equations K, A, B. Let's see if we can do this. I'm not sure, to be honest. Let's just try it. So if I was doing a problem like this, you know, we have our solution for product of solutions, which is C over A, but we're going to pretend we don't know that. So 57 x squared plus 57b plus a, hold on, times x plus a times b, and we'll add sliders. Okay, and then hold on. Oh, wait a minute. And then my solutions are -1 and that. Hold on, what if I change this constant to 2? How about 4? I'm just trying to make easier solutions. Or how about -5, -4, whatever. Okay, fine. I'll just leave it like that. 0.07 and -1. And then those are my two solutions. And then KAB, and then we need KAB, and we need KAB to be equal to -1 times 0.07, which is -0.07. Okay. And then now I can plug in these values for K. Hold on, let's try this. Let's see if this works. See again, do you see how it's glitching? I gotta close it and reopen it. Okay, so let's try that. So let's try, well, right now it's -4. It needs to be, it's gotta be 1 over 57 or 1 over 19. So, come on, dog, don't glitch. Calculator. Okay, hold on. 1 over 57. Too small. It's gotta be 1 over 19. Let's go, come on. Ooh, that doesn't work. 1. Oh, I was looking at the wrong thing. 1 over 57. Oh, it's 1 over 57. Look, you get the -0.07. I was looking at the wrong thing. Oh, look at that. We got him. Really hard question. This one, I don't think you can do in Desmos. I bet you it's going to be some weird decimal, but we're going to try here. So they said a circle. We want the radius, so x squared. Because if it's this level problem at this point in the game, it's probably going to be hard. Plus y is equal to 199 over 2. Okay, so what is the length of this radius? It's not even centered at 0, 0. It's centered at x plus 1. I think it's centered at -1, -1 is what it looks like. And I don't see how we can do this in Desmos with just this. Right? No, it's not -1, -1. What am I talking about? You take half of that. It's 1/4. It's -1/2, -1/2. Again, it's not like you'll know that. So we're just gonna have to. We're not gonna be able to do this. And then what is the top value? I don't even know. Oh, you can do it. Look, you can see the top value at 9.5. So if you can get that the center is there, the radius is 10. I think we can count that. I think we can count that because you could estimate, and it is a nice whole number. I think we can count it. All right. 90 centimeters. Base of each prism is a square, and I've seen this problem. There's no way. There's too much interpretation that you need to do to piece it together. So I'm going to skip it and leave it blank. And then this one has vertex, boom, and intersects the x-axis at 2 points. We could totally do this in Desmos. Ready? Watch this. So we got ax squared plus c. Add a slider for all. And then we want a plus b plus c. And we want a vertex at 9, -14. Okay, so let me think here. How could we do that? -b over 2a should give us the x value of the vertex. I'm kind of using too much information, I feel like. Wait, let me think. Is there any way we could do this? 9, -14. How can we bring that vertex down? I don't think it's doable. It's too hard. Okay, we'll skip it. And those are the ones that I couldn't answer. The rest, I answered like the majority. Let's see this. Okay, now we're going to see the score that you can get from purely using Desmos. Okay, convert degrees to radians. What to type the value in terms of pi or rounded decimal? It depends. If you convert from degrees to radians, I'm answering some of the questions. It depends on what they're talking about. Okay, hold on. I'm going to check see if I got my score. All right, sign in. I'm just doing it over here. What? Wait a minute. Why isn't this working? Oh. I messed up. Hold on. There we go. Okay, let's see if it's up yet or not. It's not bad. It's not bad. Look at this. I got a 590 basically without knowing anything. If you think about it, maybe a couple things here and there, but that's insane. That's almost a 600 just from purely using the calculator. So that is phenomenal. Do I have any videos talking about radicals? Yeah, I definitely do. Check out my critical concept videos. It's 9 p.m. I was about to sleep, worried about decimals. Well, there you go. This is how to use it like it's straight G. Okay, how are y'all? I have SAT exam I get 1430 last time. Which should get better? Let's go. My test tomorrow. Wish me luck. Some linear exponential equations are confusing, but thank God. I just created a video on linear and exponential, a huge section. Check out the video I released yesterday if you haven't yet. Wow, this was so cool. I hope these Desmos hacks give you a big confidence boost because, like I said, you can do a lot with Desmos. You can just, like I said, if you use it effectively, you're already at a 600. That's so wild. Anyways, I hope you guys like this video. I've been thinking about it all week, how to do it and how to present it. Thank you for the likes that you did provide. If you haven't given this video a like and you do find it helpful, if you could give me a like right now, I'd appreciate it. It helps the channel massively, helps the videos massively, so that would be much appreciated. Guys, digital SAT, we are on. We are locked in. And for anybody who's taken it after, this is for December, but if you're watching this video on replay, I wish you the best of luck. We're going to have so much amazing content. Make sure to check out the SAT crash course. It's in the description link below. There's 20, count them, 20 practice digital SATs there that are of the highest caliber, highest quality. Use the code SCALAR, SCALAR. It's all in the description. You get 20% off. So make sure to do that. Guys, do your thing. Get some sleep. Best of luck tomorrow. And I will see you in the next video. Take it easy.